Hello viewers, welcome to Kids Auto and Truck Repair. Today we have a 2003 GMC Yukon with a 6.0 liter. The complaint on this vehicle is the check engine light remains on the dash while the engine is running. So the first thing we're going to do is we're going to go in the vehicle and confirm the customer's complaint. After confirming the customer's complaint, we're going to connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. So now let's go in the vehicle and confirm the customer's complaint. So right there, as you can hear, the engine is running and the check engine light remained on the dash. So right there, check engine light is on. This is the light that the customer is complaining about. Customer's complaint confirmed. So now I'm going to turn off the engine. I'm going to turn the key on. I'm going to get the scan tool connected to the vehicle, and then I'll bring you guys back up so we can scan the engine computer. I got the scan tool connected to the vehicle. I'm going to bring it up. So we're gonna go to scan. The scan tool has identified the vehicle. Everything looks good. 2003 GMC Yukon with a 6.0 liter. So we're gonna click OK. We have one trouble code in the engine computer, and here is the code. Our trouble code is P0446, and it says Evap vent control problem. So this code over here is what's causing the check engine light to remain on the dash while the engine is running. As you can see, it says Evap vent control problem. So we have a problem in the Evap system, specifically on the vent control circuit. Now, this could be caused by an open vent solenoid or a problem in the vent solenoid circuit. We need to figure out what's causing this problem so we can fix it. Before I tell you what we're going to do next to fix this problem, let's talk a little bit about the Evap system. Let's talk about the Evap system and how it works, and then we're going to continue. I want to apologize about my voice. I sound very funny and very weird today because I have a cold. So I am sick. I'm not feeling very well, but I wanted to share this problem with you. I wanted to turn on the camera and share with you how we're gonna fix this problem. Okay, so this P0446 trouble code is usually set because there is a problem in the Evap system. Now, what is the Evap system? I'm sure most of you know, but just as a refresher, the Evap system is actually the system that routes fuel vapors from the tank to the engine, so that they can get burnt while the engine is running. Because when you fill up your gas tank, when you put gas in the tank, there are fuel vapors that are trapped in the tank, okay? And when the outside temperature is hot, on hot days, if your fuel tank is half full, the fuel in the tank is gonna evaporate a little bit, and that will cause fuel vapors. And those fuel vapors have to be routed to the engine so they can get burnt while the engine is running. If we do not burn them while the engine is running, they're going to eventually leak out in the air and they will pollute the air. So we don't want hydrocarbon polluting the air. That's why most manufacturers have created Evap systems to route fuel vapors from the tank to the engine. Okay? Now, this system on this truck, different manufacturers do things differently, but on this truck, the Evap system on this truck has two solenoids. There is the Purge solenoid and the vent solenoid. The vent solenoid is in the back by the fuel tank, and the Purge solenoid is under the hood on the intake manifold. The vent solenoid is by the tank. The vent solenoid is connected to the charcoal canister, which acts as a reservoir for the fuel vapors. So the charcoal canister is connected to the fuel tank, and then there is a tube between the canister all the way to the front of the vehicle on top of the engine on the intake manifold. There is a valve there that connects the Evap tube to the intake manifold, and that's called the purge valve. So the computer opens and closes the purge valve. The purge valve is a normally closed valve, and the vent valve is a normally open valve. So when the computer wants to purge the fuel vapors inside the intake, what it does is it closes the vent solenoid and then opens the purge valve while the engine is running to allow fuel vapors to enter in the intake so they can get burnt while the engine is running. Because the fuel vapors will enter the intake and then eventually they're gonna work their way into the cylinders and get burnt while the engine is running. The computer also uses kind of the same method to test the Evap system. So to test the Evap system for leaks, what the computer does is it closes the vent solenoid, it opens the purge solenoid while the engine is running. If you open a purge solenoid, since the purge valve is attached to the intake manifold, engine vacuum will get introduced into the Evap system. The computer allows vacuum to get into the Evap system for a certain amount of time, and then it closes the purge valve. So it closes both valves, purge valve and vent valve. And after that, the engine computer watches the fuel tank pressure by using the input that comes from the fuel tank pressure sensor. So when there's vacuum inside the tank and the Evap system and both valves are closed, the pressure inside the tank should drop because we're introducing vacuum in the system. So the computer watches that vacuum to see how long the vacuum is going to stay in the Evap system. It doesn't stay there forever, but it has to stay there for a certain amount of time. So if vacuum does not stay long enough in the Evap system, then the computer is going to trigger a trouble code. And that's how the computer tests an Evap system for leaks. Now, what we have to do now is we have to figure out if this code is caused by a bad vent solenoid or a problem in the solenoid wiring. So now what I'm going to do is I'm going to use my bidirectional control test on the scan tool to turn the solenoid on and off. These solenoids are very loud, so while we're sitting here on the driver's seat, if I turn on the solenoid, if the solenoid is good, if the wiring of the solenoid is good, we should be able to hear the solenoid click. So now let's do that. Let's see if we can turn on the vent solenoid on this truck. So we're gonna back out. We're gonna go to functional test. Let's go to output controls. Right here, vent solenoid. We're gonna click on vent solenoid. So we're gonna turn on the vent solenoid. So I'm gonna click on on. I don't know if you heard that, but I heard a click under the truck. So our vent solenoid is clicking. Now the vent solenoid clicking doesn't mean it's good, but since it's clicking, this tells me that the wiring of the solenoid is good. So this tells me that the solenoid is receiving power and it's also receiving ground from the engine computer. Okay, so now I'm gonna do the evap purge/seal test. We're gonna command the engine computer to open the purge valve while the engine is running. Now we're gonna customize this list. I just wanna look at a couple data pads. So we're gonna grab our vent solenoid, purge, fuel tank pressure. Okay, so these are pretty much the only data pads that I wanna look at. So I'm gonna grab the fuel tank pressure sensor voltage pad. Now, right now, our vent solenoid is not venting. Remember I said the vent solenoid is a normally open solenoid, but since we're doing this purge test, the vent solenoid is not venting, so it's closed right now. And our purge valve is also closed. Now what I'm gonna do is I'm gonna start the engine. We're gonna watch this fuel tank pressure sensor graph. When I start to open the purge valve, since the vent solenoid is closed, we should start dropping pressure inside the tank. And this voltage over here should change. The voltage on this graph should change when I open the vent solenoid. So let's see what happens. I'm gonna start the engine. So as you can hear, the engine is running. I'm gonna open the purge valve. So we got the purge valve opened at 50%. We're gonna keep increasing. So the purge valve is opened at 80%. So I'm gonna seal the system. So the purge valve is open, the vent valve is closed, but our fuel tank pressure graph did not change. Our fuel tank pressure sensor voltage did not change. And even the inches of water graph over here didn't change. So since our fuel tank pressure sensor input did not change, this tells me that we either have a large leak in the evap system, or we have a purge solenoid that's not opening, or maybe we have a vent solenoid that's not closing, or we could also have a gas cap that's not closing all the way. So there are a couple of things that can cause this. So let's go down here. I hope you guys can hear me because my voice sounds very weird. I hope you can understand what I'm saying. Now, let's do this again. We're gonna open the purge valve. Let me graph the purge valve also. As you can see, we're opening the purge valve. So we opened the purge valve up to 90%. We're gonna seal this. Okay, we sealed the purge valve. And our fuel tank pressure sensor data PID is not changing. Okay, our fuel tank pressure sensor data PID is not changing. So this is what's causing this trouble code to be set in the engine computer. I'm gonna turn off the engine. So guys, what's happening here is when we are opening the purge valve, our fuel tank data PID is not changing. Okay, so now what I'm gonna do is, let's go under the hood and do some tests at the purge valve. Maybe the purge valve is not opening. We are here under the hood. Here is our evap purge valve. It's right here on top of the engine. This is the evap tube and this is the evap service port. We're gonna disconnect this tube so we can test our evap purge valve. Now to test the purge valve, we're gonna use this vacuum gauge. We're gonna attach it to the purge valve. So I'm gonna disconnect this tube. So I pushed on this plastic locking piece and pulled the valve up. So now we're gonna connect our vacuum gauge to the purge valve. Okay, so just like that. Now, as you can see, our gauge is reading 0 vacuum on the gauge, 0 inches of water. Okay, so we're good. So now I'm gonna go inside the vehicle and start the engine. With the engine running, we should not have vacuum on this side of the valve because this valve is normally closed. We should only have vacuum on this side of the valve when the valve is turned on. Okay, when the computer turns on the valve, that's when vacuum flows from the intake to the evap system. So now I'm gonna go in the vehicle and start the engine. So watch that gauge. We still have 0 on this gauge. So this is good. We don't have vacuum leaking from the valve. So now I'm gonna grab my scan tool so we can turn on the purge valve. I'm gonna turn on the purge valve with my scan tool. So watch the gauge. Let's see if this gauge is gonna move. As you can see, the gauge went up. So the purge valve is working. You see the gauge went up because I just opened the purge valve with the scan tool, okay? So our gauge went up, so the purge valve is definitely working. I'm gonna disconnect this to release the vacuum. So the purge valve is definitely working. I'm gonna do that one more time. Watch the needle on the gauge. So I'm gonna open the purge valve. Watch this. You see how the needle went up? So that's good. Our purge valve is working. So I can exit this test. I'm gonna go in the vehicle and turn off the engine. All right, so our purge valve is definitely opening. So now what we're gonna do is let's lift up the vehicle and go under the vehicle so we can test our vent solenoid. We are here under the truck. This is our vent solenoid. So I'm going to turn on the vent solenoid using the scan tool over here. And I want you guys to listen to the noise that the solenoid is making when it's turned on. And I hope the solenoid is closing. So when I turn it on, there's a clicking sound. I hope you can hear that. And our PID is changing. Now it's venting. Now it's not venting, venting. So I'm gonna show you the solenoid here. And I hope the camera is gonna pick up the click. I hope the camera is gonna pick this up. You hear that? So I hope it's loud enough to the point where the camera can pick up the click. So let's do that one more time. On, off, on, off. So our vent solenoid clicks. So what's the problem? I'm gonna show you the scan tool again. So here's what we're gonna do. Since our vent solenoid is clicking, our purge valve is working, but we have this code in the engine computer. Let's see that code again. P0446 Evap vent control problem. We don't have a vent control problem because our vent solenoid is coming on and off. It clicks. We know the wiring of the vent solenoid is good. The solenoid is clicking, so it's most likely good. Our purge valve is working. The wiring of the purge valve is good. So what's causing this code? So now what I'm gonna do is, let's back out. I'm going to use a vacuum machine. I'm gonna use a smoke machine, not a vacuum machine. I'm gonna use a smoke machine to send smoke down the system, down the Evap system. So we're gonna turn on the vent solenoid, so we're gonna close it. But before we do that, I want to look at my fuel tank pressure data PID. So let's customize this list. Let's grab our vent, purge, fuel tank level. So I'm going to graph these two data PIDs over here. Okay, so right now our vent solenoid is venting. Our purge valve is closed. The engine is off, and our fuel tank pressure sensor is showing us 0.2 volts and 6.41 inches of water, which we had before. Okay, now let's go under the hood. Let's get our smoke machine fired. We're gonna induce smoke in the Evap system, and then we're gonna close the vent solenoid. This voltage over here should change. The voltage on the fuel tank pressure sensor graph should change when we send smoke inside the tank. if this voltage doesn't change when we close the vent solenoid and induce smoke in the evap system, if this fuel tank pressure sensor voltage doesn't change with smoke in the evap system, that will tell me that this fuel tank pressure sensor is not working. And then we're gonna have to lower the fuel tank to do some test at this sensor. And I'm pretty sure this sensor is going bad. So now let's go under the hood and do that. We are back under the hood. My smoke machine is ready to go. It's connected to the battery and to the air line. So now I'm gonna remove the cap on the evap service port. And then I'm gonna remove the shredder valve that's down here. So here comes the shredder valve that's on the evap service port. Now I'm gonna thread in this adapter here. We're gonna turn on our smoke machine. We're gonna wait until smoke starts coming out of this tube. So while I'm waiting for smoke to come out of this tube, I'm gonna grab my scan tool so we can close the vent solenoid. I see smoke coming out of this tube. Now, if we don't have a leak in the evap system, when the system is sealed, this check ball over here is gonna go down. So if I close this, you see how this ball goes down? So that's an indication of a sealed system. So if the check ball goes all the way down, it means the evap system is sealed. Okay? So we got smoke coming out of this tube. So now I'm gonna close my vent solenoid. When I close my vent solenoid and we induce smoke in the evap system, we're gonna watch this fuel tank pressure data pid. This graph over here should change. Right now, with no smoke in the evap system and the vent solenoid open, we have 0.2 volts. So I'm gonna close the vent solenoid. Okay, so I heard the click back there. Now, we're gonna induce smoke in the evap system. So I'm gonna connect this to the service port. Okay, so now we have smoke going into the evap system. Our vent solenoid back there is closed. Okay, now the gauge, the check ball is dropping now. This is a good sign. Okay, this tells me that the evap system is sealed. This tells me that we don't have a leak somewhere in the evap system. Now let's look at our fuel tank pressure data pid on the scan tool. So our fuel tank pressure sensor is not changing. So let's observe it for a little longer. Now, this fuel tank pressure sensor is a 3-wire sensor. That sensor is supposed to have ground, 5-volt reference, and a signal. So that sensor is what tells the computer if the evap system is leaking or not. So our check ball on the smoke machine is going down. That's good. But our fuel tank pressure sensor data pid is not moving. So we have a bad fuel tank pressure sensor, and this is what's causing the trouble code to be set in the engine computer. Our vent solenoid is good because if we had a vent solenoid that was stuck open, this check ball was not gonna drop like this. We can go around the truck to see if we have smoke leaking out of somewhere. We don't have smoke leaking over here. If we had a leak, that check ball on the smoke machine wasn't gonna come down like that. Okay, so if we look under the truck, there's no smoke leaking anywhere. So we're good. Our evap system is sealed. Okay. Our problem is our fuel tank pressure sensor. Yeah, look at that. Our check ball went down even further. This is really good. Like, this is normal. Okay? But look at our fuel tank pressure sensor. Fuel tank pressure sensor is stuck at 0.2 volt. This voltage should change, okay? And this inches of water data pid over here should change. So remember these two data pids. So the fuel tank pressure sensor is not telling the engine computer what the actual fuel tank pressure is. Okay, so remember these numbers. So the fuel tank pressure sensor is bad. Okay, so I can turn off my smoke machine. Actually, the smoke machine just timed out. So I can turn this off. We're good. Okay, this is stuck. The check ball is stuck down here, so which tells me that our system is sealed. I can disconnect this line. Now we just created a leak and our check ball went up. So we have to lower the fuel tank so we can get access to the fuel tank pressure sensor. So I'm gonna turn off my smoke machine. Okay, so when we induce smoke in the evap system, our fuel tank pressure sensor voltage data pid is remaining at 0.2 volt, regardless of what's happening in the tank. Whether there is pressure or not, this fuel tank pressure sensor is not updating the engine computer. It's not telling the engine computer what's going on in the tank. So we have to get to the tank, and you will see when we replace, hopefully the problem is just a sensor, hopefully we don't have a wiring problem. You will see that if the problem is just a sensor, after we replace it, these graphs here will be updating when we send vacuum in the evap system. Let's go under the truck and lower the fuel tank. We are here under the vehicle. Here is our fuel tank. This is the charcoal canister. This is the fuel tank right over here. Now the fuel tank pressure sensor is up there. It's above the tank. So I'm gonna have to undo these fuel tank straps. There's one over here and there's another one right over here. Now we don't have to remove the fuel tank completely, but we have to lower it, okay? The fuel tank has to come down a little bit. So I'm gonna lower the fuel tank off camera and then I'll bring you guys back up. We have lowered the fuel tank. As you can see, I got this fuel tank strap off. The other strap over there is off. So now we can get access to the fuel pump sending unit. So if we go up here, you'll see that now we have access to the fuel tank pressure sensor. So this electrical connector over here is the electrical connector of the fuel tank pressure sensor. As you can see, it has 3 wires on it. I'm going to back probe all those 3 wires, and then we're gonna use our lab scope to check the wiring of the sensor. We should have 5 volt on one of these wires, ground, and then signal. If the wiring check out okay, then we're gonna go ahead and replace the sensor. I'm pretty sure the sensor is bad, but we're not just gonna replace the sensor. We have to test the wiring first, okay? I'm gonna get all these wires back probed, and then I'll bring you guys back up. I got my lab scope set up, and I'm back probing all the wires at the fuel tank pressure sensor electrical connector. So now, let's look at the lab scope. Everything is connected up here. So now, let's go down to the scope. I'm gonna go in the vehicle and turn on the key. As you can see right now, we are reading minus 0.04 volt on the yellow trace, 0.01 volt on the green trace, and then minus 0.02 volt on the blue trace. So I'm on the voltage scale. I'm gonna go in the vehicle and turn the key on, and then we're gonna come back to the scope and see what voltages we have on the scope. So now I'm gonna go in the vehicle and turn the key on. I have turned on the key inside the vehicle. So now let's see what we have on the lab scope screen. All right, so right now with the key on, we have 5 volt on the blue trace. So the blue trace is our 5 volt reference. And then we have 0.25 volt on the green trace, and then 0.00 volt on the yellow trace. It's going between 0.00 and minus 0.01 volts. So the green trace is our signal. So green trace is the sensor signal, yellow trace is the sensor ground, and then blue trace is our 5 volt reference to the sensor. Okay, so the sensor is getting power and ground. This sensor is bad. The wiring of the sensor is good. So at this point, I feel comfortable replacing this sensor. So let's go back up here. Let's go back up here and disconnect this sensor. I'm gonna go ahead and remove these test leads. So we are done with our testing. So the sensor wiring is good. So now we can go ahead and remove the sensor. So I'm gonna reach up there and disconnect the sensor right there. So I got the sensor connector disconnected. So the pins on the sensor connector look good. They are not corroded, so we're good. So now we're gonna remove this fuel tank pressure sensor. We're gonna spray some WD-40 around the sensor. So this sensor just pops in, so I'm going to gently pop it out. There. I hope you can see that. So here comes our sensor. The fuel tank pressure sensor is removed. The little rubber that goes over here is stuck on the fuel pump unit, so we're gonna have to remove that before we install the new one. So I'm gonna get this sensor out of the way. I'm gonna order a new sensor. After the new sensor comes in, I'll bring you guys back up so we can install it. So this here is the problem. Okay, bad fuel tank sensor. Once we install a new fuel tank pressure sensor on this vehicle, the P0446 trouble code will be fixed. I'm gonna get a new sensor and then I'll bring you guys back up. I have received a new fuel tank pressure sensor from the parts store, and here it is. This is the part number. Okay, so this is the old sensor. This is the boot that goes over here. I had to remove this off camera because this boot stayed on the fuel pump assembly. Okay, so now we're gonna install this sensor. So here is our brand new sensor. So here is our brand new fuel tank pressure sensor. Let me get it out of the bag. So this is what we're gonna install. And after we install this vehicle is gonna be fixed. Okay, so now I'm gonna install our new fuel tank pressure sensor. So I'm gonna push it right here in its hole, and then I'm gonna push it down just like that. All right, so the new sensor is installed. So now I'm going to reconnect the electrical connector of the sensor. We're going to connect it to the new sensor. So just like that, our brand new fuel tank pressure sensor is installed. So now I'm going to reinstall the fuel tank. So now we're going to put everything back together. I'm going to lift up the tank and tighten the bolt of the fuel tank straps. And after that, I am going to lower the vehicle so we can verify our repair. I have lowered the vehicle. Now let's verify our repair. We're gonna reuse our smoke machine to see if our fuel tank pressure sensor data pid on the scan tool is going to change when we send smoke in the Evap system. I'm sorry for my voice once again. So now let's do that. So right off the bat, there is a difference now with the data pid on the scan tool. So look at this. So now our fuel tank pressure sensor is showing a 1.5 volt. Remember before it was stuck at 0.2 volt. And now we have 0.03 inches of water. Before it was stuck at 6 point something inches of water. So this is good already. This tells me that this is fixed. Just based on this voltage value that we have over here on the fuel tank pressure sensor data pid, this tells me that this is fixed. Now, we still have to verify our repair before we take this on a test drive. So I'm going to turn on my smoke machine. I still have this adapter connected to the Evap service port. Let's wait until smoke starts coming out of this. We now have smoke coming out of this tube. When I send smoke in the Evap system, our voltage PID should change on the scan tool. If everything is fine, if the system is sealed and everything is good, our voltage PID should change. So check this out. You see, our inches of water PID are already changing. So this is changing already. Our voltage is changing. So we're gonna have to give this a couple minutes until smoke is filled throughout the Evap system. So this is good, guys. This is fixed. Actually, I didn't close the vent solenoid. I'm gonna disconnect this line again. We have to close the vent solenoid first. Okay, so let's close the vent solenoid. Now it's venting. Let's close this. So the vent solenoid is closed. So now we're gonna induce smoke in the Evap system. Now the system should be closed. Now you'll see a quick drop. So watch this. Now we're talking. Yeah, baby, this is wonderful. Okay, so our inches of water data pid is increasing and then our voltage is dropping. Okay, so this is increasing, so so pressure in the tank is increasing and then voltage is dropping. Okay, and our check ball on the smoke machine is dropping. So perfect. This is fixed, guys. I feel comfortable with this. Check this out. So our voltage PID of the fuel tank pressure sensor is decreasing. Okay, we are now reading 0.3 volt and we have 6.41 inches of water. This is good, guys. Perfect. So this is fixed. Now I'm gonna put everything back together and then we're gonna take this vehicle for a test drive. I got the truck off the lift. So now let's go in the vehicle so we can verify our repair. I already got the scan tool connected to the truck. So now I'm going to start the engine so I can show you the check engine light that's still on. Right now the check engine light is still remaining on the dash. Okay, so check engine light is on. We did the repairs. We replaced the fuel tank pressure sensor. So now I'm going to erase the trouble codes, and then we're gonna test drive this truck. So I'm gonna bring up the scan tool. So we're gonna go to scanner. So now we have a Evap pressure sensor signal low trouble code. So I'm gonna back out. I'm gonna clear the code. So we got all the codes cleared. No codes present, so we're good to go. I'm gonna start the engine. So right there, the engine is running and the check engine light is off. So now we are going to test our Evap system. So let's back out. We're gonna go to functional test. We're gonna do the Evap Purge / seal test. Remember before, when I was doing this test, our fuel tank pressure voltage value was not changing. Our fuel tank pressure sensor voltage value did not change. So we're gonna customize this list. I'm gonna look at these speeds over here. So that's it. We're gonna graph these. As you can see, there's a big difference between now and what we had before. We're gonna open our purge valve. You see how this is changing now? We have vacuum going in the tank and our voltage is increasing. So now I'm gonna seal it. Right there. Perfect. So this is good, guys. And the system is holding vacuum. So we're good to go. This is fixed. So I'm gonna back out. We actually don't have to test drive this. I know this is good, okay? This is fixed, guys. This is good. So just for the heck of it, let's do a quick loop around the shop, and then when we get back, we're gonna wrap up this video. So we're good to go. This is fixed. We're gonna have a happy customer. So before we replaced the fuel tank pressure sensor, the fuel tank pressure sensor data on the scan tool, the voltage data was stuck at 0.2 volt, and the inches of water data was stuck at 6 inches of water and something. So now everything looks good. We're good to go. So this is fixed. I feel comfortable delivering this back to the customer. So this is good to go. This truck is fixed. Let's get back to the shop so we can wrap up this video. All right, so we are back at the shop. Let's put the vehicle in park. I'm gonna turn off the engine. I'm gonna turn the key back on. I'm gonna bring up our scan tool. Let's scan the engine computer once again before we wrap up this video. So let's go to codes. No codes present. So that's good. We're good to go. I'm gonna leave this right over here. This truck is fixed. The problem on this truck was a defective fuel tank pressure sensor. We replaced the fuel tank pressure sensor. Now all is well. Now, I apologize for my voice. I sound weird and different. It's because I'm sick. I had to come into work today, and this was a pretty interesting one, so I wanted to share this with you. So when I edit this video, if the sound is not too bad, I'm gonna upload this video. But if it's bad and you cannot really hear me, I'm not gonna upload this video. So maybe you'll see this video, maybe you won't. But if I end up uploading it, I wanted to tell you that I'm not feeling well and I apologize for my voice. I have a cold. Actually, I'm starting to feel a little bit better, but it was worse the past few days. Now I'm starting to feel better. So I hope you were able to understand what I was saying. And yes, so I'm gonna leave this right over here. Thanks for watching. If you have any comments, questions, criticism, leave them in the comment box. If you like the video, give it a thumbs up. If you don't like the video, give it a thumb down. But if you do, you gotta tell me why so we can make better videos in the future. If this is your first time here, subscribe to the channel. Ring the bell so you can get notified every time I upload a new video. If you have any comments, questions, criticism, leave them in the comment box. Thanks for watching. See you next time.